Hi folks, it's a part 2 video of the exercise 5.2. Let's continue. We were doing the modulus and the argument first, then we started doing the polar form. Now polar form, how was it? We were finding the argument. We were with the given complex number, we were writing it as r times cos of the argument plus I times sine of the argument. That's how we were doing it. So let's continue with that. Only some challenging times are there when you get suppose say your argument is beyond the limits of minus pi and pi, then we don't call it as an argument, and to actually make it fall in the normal range, we have to use the formula minus of 2 pi minus the angle that you have got, then you get it in the normal range. So that was just one small twist that you should know whenever you are doing your problems. So we continue with problem number 4. We have to express it in polar form. Let's see how it is. You have the problem minus 1 plus I. So what do we know here? Here x is minus 1 and y is 1. So what is your r? It is root of x squared plus y squared, which is minus 1 squared plus 1 squared, that's 2, root 2. So r, you have got the value. Now you have to take the value of, we know that, cos theta is x by r and sin theta is y by r. That means cos theta is minus 1 by root 2 and sin theta is 1 by root 2. Therefore, the argument is, see, cos negative, sin positive, second quadrant. The angle is of the type pi minus theta. Now theta, that we can get, the magnitude you can get from these angles. What is that angle whose cos is 1 by root 2, and what is that angle whose sin is 1 by root 2? It is 45, that is pi by 4. So it is of the type pi minus pi by 4. Now because it is pi minus, it will fall in the normal range. So we have no problem. This will come to 1 into 4 into 4, 4 pi minus pi by 4, 3 pi by 4. That's how this will come. Now, how do we express it in polar form? Minus 1 plus I in polar form is r times cos of the argument plus I times sine of the argument. That's all. You have got it in polar form, right? From one form to the other form. Okay. Can we move to the next problem? Minus 1 minus I, here x is minus 1, y is minus 1, r therefore is root of minus 1 squared, that is actually 2, root 2. Also, cos theta is x by r, sin theta is y by r. So cos theta is minus 1 by root 2, sin theta is both are negative, which is that angle. Yeah, this is that angle where this happens. That quadrant, right? So it's pi plus theta. And again same thing, 1 by root 2 is always pi by 4. Cos of which angle is 1 by root 2, sin of which angle is 1 by root 2, it is 45. So it is pi plus pi by 4. Or rather, if you could equalize it, 4 pi plus 5, 5 pi by 4. But it falls in the range which we don't appreciate. So we get it into our normal range by writing minus 2 pi minus 5 pi by 4. Okay, so how do we equalize this? Into 4 into 4. So how much does it come to? 8 pi minus 5 pi by 4, 3 pi by 4. So this will come to minus 3 pi by 4. And when we write it in polar form, how will it come? Minus 1 minus I is r times cos of the argument plus I times sine of the argument. That's how we go about it, and that's our form. Can we move to the next 6th problem? Simple problem. I think the last 3 should be simple. Let's see, I feel. Okay, minus 3. So here our x is minus 3. So actually minus 3 means minus 3 plus 0, and y is 0. So what is r? It is root of minus 3 squared plus 0 squared. That is root of 9. That is 3 only. So r is done. Also we will have cos theta as x by r, minus 3 by 3 minus 1, and sin theta as 0 by r. So 0 by 3, 0. Which is this angle? I know it. Whether you all know an angle whose sine is 0 but cos is minus 1? Which is that angle whose sine is 0 and cos is just 1? Yeah, this we should know. If you don't know it, we should know it, that if the sine is 0 and cos is minus 1, then that angle is pi, 180 degree, right? So this will allow us to know that the angle here is pi. So no need for any extra work. We have, once you know the proper angle, all this is not required. If you know it is pi by 6, if you know it's pi by 3, if you know it's pi, if you know it's pi by 2, then there's no need to do all this. When we don't know all that, we do all this work, right? So therefore, the argument is pi. So what's polar form? Therefore, minus 3 in polar form can be written as r times cos of the argument plus I times sine of the argument. Alright, that's about it. Next problem, root 3 plus I. Here, our x value is root 3, y value is 1. How about r? It is root of root 3 squared plus 1 squared, which means it is 3 plus 1, root 4, our good old friend 2. I was wondering why 2 is not coming. All this time we were getting something, 2, we were getting 3, 1, something and all. But we were not getting 2 initially. First 2 problems we were getting 2 continuously, and then no 2. I was wondering where our old friend went. Okay, finally we found our friend, r(2). Cos theta, right? We know that. Cos theta is x by r, which is root 3 by 2. Sin theta is y by r, which is 1 by 2. Oh, these are good children because they both are positive. They lie in the first quadrant, you will get the precise value. So, argument. What is the argument? Which is that angle whose cos is root 3 by 2 and whose sine is half 30, right? So, it's pi by 6. So, absolutely easy this one. When we write it in polar form, root 3 plus I becomes r times, that is 2 times cos of the argument plus I times sine of the argument. And we are done, isn't it? Okay, can we take the last problem? 8th I. I means 0 plus 1i. So what happens? X is 0, y is 1. So what is r? 0 squared plus 1 squared, that's 1 only, right? R has become 1. Okay, how about cos theta and sin theta? We know that cos theta is x by r, so 0 only. Sin theta is y by r, that's 1 by 1, 1. Okay, which is that angle which gives cos as 0 and sine as 1? 90 degree? Yes, 90 degree. Therefore, the argument is 90 degree pi by 2. So, what's our polar form? 0. Oh, should have been written like that. I we would have wrote. I equal to r times cos pi by 2 plus I sine pi by 2. That's all. That's how we finish this exercise. There is one more exercise left in this chapter, and of course we have the miscellaneous. That's how we wind up this chapter also. Thank you.